Let's do two more examples for inverse trig functions and indefinite integrals. The first one is 1 over x times the square root of x to the fourth minus 100. Now this one's a little tricky because you might say to yourself, okay, well, I know that this kind of looks like an arcsecant because an arcsecant has an x and an x squared minus 100, but I don't have x squared, I have x to the fourth. So what happens if I do something like picking x squared to be u? So if I rewrite this and I say, okay, well that's if I have something that I'll write like this, okay, well that's something squared minus 100, but the something here doesn't match the something there. So I still can't quite pick u like that, or at least so I think. But sometimes it's helpful to just pick a u, even if you don't fully understand how you're going to get there. Try to pick a u and follow it through and see if it simplifies. If it doesn't, whatever, you wasted a little bit of time. But it's always worth to kind of probe at the problem. So let's try to do that. Let's say, okay, I'm going to let u be x squared anyway. So that tells me that du is 2x dx. Now I need to be careful here because this doesn't quite work out, but I'm also going to say if u is x squared, I'm going to let x equal the square root of u. Again, that's a problem because in the case where this should be okay, but you could have cases where like x is negative, so it doesn't quite work out right. So again, you have to be careful with this. But going back to our original problem, let's replace some things. I'm going to get sorry, I went ahead and did that replacement so we can replace it up here. That's 1 over 2x du, and then we have x u squared minus 100. Okay, now that we have that, let's simplify this even more. Let's bring that 1/2 all the way out. And let's bring that x down here. So I have du for x squared u squared minus 100. Okay. But I know that x squared is actually u, so that's 1/2 du or u times u. Now instead of 100, let's just write 10 squared. So that tells me that and this is u squared. So this tells me that it actually resolved. It actually just worked itself out. I didn't have to use this substitution, even though I could have. So by doing that, okay, everything's in line. I see that a is 10. So my answer is 1/2 divided by 10 times arcsecant u over 10 plus c, at which point then I'm going to resolve this into 1 over 20, and u is equal to x squared, so I can say arcsecant x squared over 10 plus c, and I can remove the absolute value because x squared is never going to be negative. Alright, that's how we solve that particular one. Let me check my notes real quick. Looks good. Let's do this one. Alright, so I have 4 over x times the square root of 16 minus natural log of x squared dx. Now in this particular case, this looks a lot like an arcsecant. You've got an x and you've got something minus x squared, which doesn't quite look like an arcsecant, right? It looks because this isn't here. So that's a little bit odd, but I have this natural log. So it's natural to just say, hey man, can I let u be the natural log and see if that just makes my life easier? So let's try it. So we know we take u to be the natural log. Du is 1 over x dx, which we can write as x du equals dx. So let's start plugging some things in. We get 4x du over x 16 minus u squared. Well, that's pretty convenient, right? Those x's are going to cancel. So I'm going to pull this 4 out. Okay. And then what I recognize is that I can rewrite this as something squared. So then I can use the arcsecant or arcsine formula, because this is an arcsine template. So that's 4 arcsine u over 4 plus c, but remember u is the natural log of x, so that's 4 arcsine natural log of x plus over 4 plus c. And those are just, again, those are a couple more examples, and we're going to do just one more and try to really round out our knowledge on this particular topic.